Y para finalizar este tercer bloque, invitamos al escenario a Olivia Graham, quien nos presentará el proyecto Open Building de Google, una exposición galardonada con el premio a la Innovación del Año. Esta presentación será realizada en el idioma inglés, sin embargo se proyectará en español para su mejor comprensión. Olivia, tienes la palabra.
Buenas tardes. That's all the Spanish you'll be getting from me today. I'm so sorry. I'm so happy to be here. My background is not in geography. It's in computer science and in AI. And so I'm so glad that I can sort of tell you about the work that we're doing and also learn a ton from you over the course of the great presentations today. So my topic today is the Open Buildings Project, where we've used artificial intelligence to create digital maps. And I'm going to move over here. So I actually don't feel like I need to tell you what the problem is. Maps and geospatial data are fundamental for everything, from resource planning to crisis response to making sure that people are reached by vaccines. But unfortunately, not everywhere in the world is equally served by maps. And a team member of mine saw this firsthand. He used to work for the UN Global Pulse, in Kampala, Uganda, and when planning interventions, he heard that there were areas for which they simply didn't have data. They didn't know how many people lived there, or what kinds of interventions would be most effective. And this problem is only becoming more significant over time. Populations are growing rapidly, more and more people are moving into cities, and so we wondered if we could better understand where people live, using AI, using new technology, more frequently than every 10 years, which is usually how often a census is conducted. And we want to think about how we can make sure that everyone is represented and accounted for in decision making. So for some context about the project, it's part of our Google Research Africa portfolio. We have an office in Accra, Ghana, and we're focused on applying AI to see if we can make a difference in really big, difficult problems. Can technology help us to build solutions at scale? We focus on a couple of key areas, from multilinguality to weather forecasting and geospatial understanding, which is, of course, what I'll be telling you about today. Okay, so we want to use AI to better understand the world and the built environment. How are we going to do this? Well, when training AI models, the first step is always curating large data sets. And so our team got to work. We used human labelers to create a diverse data set of building polygons around the world. So you can actually see that here. On the right is overhead satellite imagery, high-resolution overhead satellite imagery. And on the left is what our human labelers have gone ahead and annotated the image. We used a diverse set of images across various villages, densely populated urban areas, to make sure that the model would be performant across a variety of areas. And this is what we built. So it's an AI model that is able to take high-resolution satellite imagery, identify which pixels are likely to be a building based on what it's learned from all of the data that we fed it, and then we actually turn those rasters into polygons, because we've heard that those are much easier to work with. I'm seeing some nods in the crowd. Great, so we have satellite imagery, we turn these into polygons, those become what we call the Open Buildings data set, and we make sure to include other valuable attributes with the polygons themselves. So like I said, a big focus of this project was to make sure that it would work across a diversity of areas. And so when we were training the models, we made sure to give it really difficult examples. Small villages like the ones you're seeing here, or areas where buildings are made of makeshift materials or very closely packed together. Our focus is on developing economies. Like I mentioned, the project started in our Ghana office, but we've seen that this kind of work and this kind of technology can be useful all over the world. Not just in Ghana, but in India, in Chile. We even get requests sometimes in the US where there's still data gaps. And so this is what we do. We have images, and we're able to segment those into polygons and use those to produce maps. All right, and so what is the result? We have a model, but a model is only useful if you're able to run it and if you're able to sort of empower people to actually have an impact with the data. And so what we did is we ran the model across the world, and we used it to generate a data set that we call the Open Buildings data set, which contains 1.8 billion polygons. They're available for free online on our website, and we've seen organizations from governments to nonprofits to NGOs download them and use them for a variety of use cases. It's really surprised us, from, again, crisis response to planning to informing a pre-census. I'll show some case studies more in a moment. Some more case studies in a moment. We also have made sure to feed this data back into Google Maps to make sure that Google's products have accurate representations of where people live. And these models are actually responsible for 60% of the buildings that we show in Africa and 40% of buildings all over the world. So here's an example. I've pulled up some data for Santiago, and you can see the polygons. Our data set includes, for each polygon, its centroid, so the center, its latitude, longitude, the area in meters, how confident our model is that this is a building, because it's not perfect. Sometimes we mistake sheds or solar panels even for buildings. But it's a good starting point, and we include the confidence so that people can filter based on their specific use case. We also include the geometry of the polygons and then the full plus code. So if you haven't heard about these are digital addresses. The technology was developed by Google Maps, and the idea is that if you're in a rural area where streets aren't named, this is an accurate address that is easier to represent than latitude and longitude, for example. And we only recently actually launched this data in Latin America. So like I said, the project started in Accra in Ghana, and our focus was on the African continent. We released the data set in 2021, and then we've been expanding pretty much every year. So in 2022, we expanded to Southeast Asia, in 2023 to Latin America and the Caribbean, and we're continuing to think through how we can continue to expand the data set and make it more useful for more people around the world. In terms of regional impact so far, so this is just since we released the data set in 2023. I think they're the IDE as well, might be the INE, oh, it's right there. The INE in Uruguay reached out and said, we downloaded your data set and we used it to help plan the pre-census period. We also were curious whether we could use it to perform a records-based census in addition to the traditional census. So merging geospatial data with government records to get an interim measurement of population. This has a few advantages for them. They're able to get information more quickly and in between the census years, and it's also more cost effective. And so we're excited to see what they continue to do with this data, and they were also able to use the plus codes for digital addressing, which is great to see. Crisis response. So often when there's a crisis event, the first question is how many people, what kind of infrastructure was impacted? And we've seen organizations use our data to answer this question, but also specifically in this use case, to do something in advance. So Google is working with the IRC and Give Directly through our Floods program, which uses artificial intelligence to forecast flooding, to register households and provide anticipatory aid before a crisis event occurs. And so you can see here on the right, they took the flood risk maps and overlaid those with our building polygons so that they could go door to door and register families and give them cash, give them assistance to better prepare for the upcoming disaster. This was in Guatemala. And then another crisis response example, also under Google Research, there is a project called SKY, which is a collaboration with the World Food Program. And what these models do is they take the open buildings model and they run it before and after a crisis event. And they're able to detect, depending on the type of crisis, what the impact has been. And so what you're seeing in red are all the places where the model has detected major or minor damage after a hurricane. This was Hurricane Otis in Mexico. And so these are just a couple of use cases that I wanted to highlight for you all. But what I really want to emphasize is, what we are good at is at training models and producing data sets. But the people who are really going to have an impact with this is you all. With the things that you discover, with the policies that you plan, it's really in your hands. I fear I'm over time, so I'll try and keep it quick. But what's coming up? What's on the roadmap? So there's two limitations to this data set that we are acutely aware of. The first is that acquiring high-resolution overhead imagery can be expensive, and sometimes it's just not available, especially for a crisis event, right? Maybe there wasn't a satellite flying overhead that day. So that's our first issue. And our second issue is temporality. It's nice to have a singular snapshot of an area, but how can we understand how regions have changed over time? Was a building here a year ago? Was this community this size last year, or has it doubled? So these are really important questions that our partners kept asking us. And so we wondered, could we take new technical approaches? There's a satellite constellation called Sentinel-2, which is maintained by the European Space Agency, and it produces these really low-res, I want to say it's 10-meter resolution images. And we wondered whether we could train models to take several frames of that imagery and super resolve it into something that is more highly featured and highly detailed. The other thing is that the Sentinel-2 constellation revisits everywhere around the world every 5 days. And so there's lots and lots of this imagery. It's also free and open source. But like I said, it has disadvantages. So here's an example of the results that we've been able to show. This is an input image. And we're starting to see early results where we can super resolve individual building footprints from that very blurry, low-res imagery. And so we're thinking through, what could this unlock? This is, I hope it replays because it's going very quickly, but month-by-month snapshots of a growing area in Ghana where you can actually see new buildings being added to the map. The buildings are the green dots, if that wasn't clear. So we're thinking through, what kind of analysis could people do with this information showing how cities and communities are expanding over time? All right, so that's an overview of the project, the work that we're doing to leverage AI to advance geospatial understanding. And because I have you all here, because you're my prisoners for the next minute, I wanted to share what you can do today and what you can use today. So I've put up a couple of QR codes. This is our paper where we explain the approach that we took to extract the polygons from high-res imagery. This is our Earth Engine catalog, so all the data is available right here. This is our website where we explain more about the project and have some FAQs. And then there's also stuff that other partners have developed, ways that they've expanded on the data set. Awesome. Thank you so much for your time.
Muchas gracias, Olivia, por compartir tu valiosa experiencia.